Hello guys, welcome to B2 Solutions. Come with me, fight with me. Okay, let's get into the video now. Today we are going to discuss about the data structures. A data structure is a particular way of organizing a data in a computer so that it can be used efficiently. The idea is to reduce the space and the time complexities of the different tasks. That's mean the algorithm which having the less time complexity that is going to consider as a best one. Okay, coming to the classification of data structures. The data structures are mainly divided into two types. One is a primitive and another one is a non-primitive. In a primitive data structures, there are 5 types. One is integer, character, boolean, float, pointer. And coming to the non-primitive data structures, these are divided into two types. One is a linear, another one is a non-linear. In a linear data structures, there are two types. One is a static that consists of array, and another one is dynamic that consists of linked list, stack, queue. Coming to the non-linear, there are two types. One is trees, another one is graphs. Now I am going to discuss each one in detail. Let's take a look on primitive data structures. These are also known as basic data structures. These are directly operated by the machine instructions. Example: integer, float, character and boolean and pointer types. These are going to store only one value at a time, but these are not going to store multiple values. Let's coming to the non-primitive data structures. A non-primitive data structure is a type of data structure that can store multiple values of the complex data types. These structures are either linear or non-linear and are essential for implementing effective algorithms. Coming to the first one, that is a linear data structure. These structures are stored data in a sequential manner. Array is a static data structure, collection of elements stored at a contiguous memory locations. This is known as array. See there, the syntax of array is any data type, array name, subscript. In that subscript, there is a size mentioned. Okay, representation of array is the elements are stored in a contiguous memory locations. Let's assume that locations are 100, 104, 108, 112, 116 respectively. Let's coming to the dynamic data structures in a non-primitive data structures. First one is linked list, a sequence of nodes where each node contains a data and a reference to the next node. The types of linked list are single linked list, double linked list and circular linked list. See the representation there. 10 is connected to 20 and 20 is connected to 30. Via links, the importance of the links in a linked list are dynamic memory allocation. That is, links allows linked list to use a dynamic memory, and the effective insertion and deletion. Using links, linked list enables fast insertion and deletion. Coming to the third one is a flexible structure. Links allows for the different types of linked list, single linked list, double linked list and the circular linked list. Coming to the fourth one, no wasted space. Because of the links, linked lists don't require a contiguous block of memory. This avoids the memory wastage and the fragmentation. Coming to the fifth one, navigation and the traversal. The link is essential for the traversing the list. Without links, there would be no way to move from one node to another node. Every algorithm that processes a linked list, like searching, reversing or sorting, depends on the following these links. Second one is stack. Stack is a linear data structure that follows the last in first out LIFO principle. This means that the last element added, that means pushed to the stack, is the first one to removed, that means popped. Key features of the stacks are LIFO order, single access point. Operation happens only at the top of the stack. Abstract data type can be implemented using the arrays or linked list. Basic operations in the stack are push, pop, peek or top. Is empty, is full. Coming to the third one in the linear data structure, that is a queue. A queue is a linear data structure that follows the first in first out principle. This means that the first element added to the queue is the first one to be removed, like a real world queue at a ticket counter or checking lines. Key features of the queues are FIFO order and the 2-axis pointer, that means a front and the rear or back. That one is the abstract data type, can be implemented using the arrays or linked list. Basic operations in the queues are enqueue, add an element at the rear of the queue, and the dequeue, remove an element from the front, peek or front, view the first element without removing it, is empty, check if the queue is empty or not. Types of queues are simple queue, circular queue, priority queue, and double-ended queues. Coming to the non-linear data structures, these structures do not store data sequentially. In this, there are two types. One is trees, another one is graphs. A hierarchical structure where each node has a value and a list of children, that is called tree. Types of trees are binary search tree, binary tree, AVL tree, heap tree. In the heap tree, there are two trees, that is a max heap and the mini heap trees. Tree traversal methods are in order, pre-order, post-order. Coming to the graphs, a graph is a non-linear data structure consisting of nodes and edges that connects pair of nodes. Graphs are used to model relationships, networks, and connections in various domains like social networks, maps, web pages, and more. Coming to the fourth one in a non-linear data structure, that is hash tables. Hash tables stores the data in a key value pairs for fast accessing using hashing techniques like linear probing, quadratic probing, and double hashing. Coming to the advantages of non-primitive data structures and applications: efficient data organization and manipulation, enhanced performance for the searching and sorting and managing data, flexibility to represent real-world relationships like maps, networks, etc. Arrays and linked lists are used in database management. Trees are used in file systems and databases. Graphs are used in social networking and pathfinding algorithms. Stacks are used in undo operations and expression evaluations. Queues are used in task scheduling and resource management.